Hi, Minnie. This is section 9.1. Okay, so midpoint and distance formula, you guys know this, right? If you don't, you're gonna remember it, you're gonna recall it, and you do need it memorized before the test, all right? So here, I have 2 points. I need to find the midpoint, and it's just like taking the average of two scores. You add and divide by 2. That's how you find the middle of 2 points. So if this is x1, y1, x2, y2, then the midpoint, what was it? It's, 5 minus 4 over 2, 12 plus 8 over 2. So how much is that? 1/2 and 10, right, guys? Yes? Okay. So here I have 2 points. Oh, oh my gosh, I solved this incorrectly in the last class because I didn't read the directions. Okay, so the midpoint is at 9, 9. So this is the midpoint. And if C is at 4, 5, we need the coordinates of D, right? So D has coordinates X and Y. So basically, C is at 4 and 5. D is at 9 and 9. No, not, this is the midpoint at 9 and 9. So I need the coordinates of D, which is like somewhere over there. All right, so how are we going to do this? So basically, the midpoint, right? So this is x1, y1, and x and y is x2, y2. So it's going to be what? X plus 4 over 2, comma, y plus 5 over 2, and that equals 9, 9. Right? That's the midpoint. So now you just have to match the x's with the x. So we're going to match this with 9. So we say x plus 4 over 2 equals 9. X plus 4 equals 18. X is how much? 14. Am I doing this right? And then we're going to match the second with the second. So y plus 5 over 2 equals 9. Y plus 5 equals 18. Y is equal to 13. So the coordinate point is 14, 13. That's where D is. All right? Yeah? Okay, so the distance formula is if you have x1, y1, then it's x2 minus x1 squared plus y2 minus y1 squared. And it comes from the Pythagorean theorem. So let's use the distance formula to find the distance here. Sorry. The first thing I do, thank you. The first thing I do is I label these x1, y1, x2, y2. And then it's just plug and chug is what we call this. So we plug it in, -2 minus 8 squared, 9 minus 1 squared. So D is 100 plus 64 in the square root. So this is the square root of 164. And if we simplify it in root form, how much would it be? 2 root 41. So 164, you break it down into its factors. It's 2 times 82. And 82 is 2 times 41.
Yeah.
So now whatever can be paired comes out. So 2, yeah, and 41 stays. And then in decimal, how much is this?
It is 12.8.
12.8, right. Okay. So now it says, use the Pythagorean theorem to find the distance between points here. So we have 8 and 1. This is the first point, 8 comma 1. And the second point is negative 2 comma 9. All right, so here's the line connecting them. And if we had to find the Pythagorean theorem, here is the triangle, right? And that's a right angle. So how much is that vertical distance?
Oh, vertical?
The vertical distance is...
Vertical is 8.
The vertical is 8 because we go from y equals 1 to 9. So the vertical is 8. How did we do that? We did 9 minus 1 basically, right? And how much is the horizontal distance? The horizontal is 10 because you got negative 2 here and that there, 10. How could you get negative 2? How can you get 10 from negative 2 and 8? You subtract them, right? And you take the absolute value. So I subtracted the y's, I subtracted the x's. Now what am I going to do to find this one? Well, it's going to be 8 squared plus 10 squared is equal to d squared. So 164 is equal to d squared. And what's d? Oh my God, it's the square root of 164, which is what we did before, right? So it just illustrates where the distance formula comes from. Okay? And look at that, 7 minutes flat for section 1. All right, so let's talk about parabolas. Okay, we've been graphing parabolas. We know it's the graph for what type of function?
X squared.
Right, so a quadratic function, right? Now, though, we're going to talk about a parabola as a conic section. And I forgot to bring my cone to show you guys what this is. But basically, you can take a cone, like a 3-dimensional cone, and depending on how you slice the cone, the part that gets sliced off, and I'll show you guys with the cone tomorrow, the part that gets sliced off is called a conic section. And sometimes the way you slice a cone, it looks, when you take that part off, it looks like a parabola. So we're going to talk about what makes a parabola a parabola. A parabola is actually something very, very special, and it's got like a million applications. Where in real life do you see a parabola? Huh? Right. Where else? A trajectory could be a parabolic shape. Have you ever seen one of those like heaters, like those parabolic, like when you go to Costco, you know, when the people that are like looking at, like checking your card, they usually have a heater behind them. Have you seen that? It's literally like it's something like this, and then it's got like something in the middle.
Oh yeah.
Right? How about a flashlight? If you looked at the flashlight, you've got the bulb, and then underneath it, you've got this aluminum curved surface. Well, guess what? That surface is a parabola. Okay? And there is a reason why it's a parabola. What else looks like that? Think sci-fi. Lenses? Yes, absolutely. Think sci-fi. Huh? No. Like, well, more realistic than that. What do you call it? The antenna, right? Or like a satellite dish or an antenna, right? No. Okay, so those are all parabolas. Okay, so why? Because if you have a parabola, we've seen this before, right? We know that there is a vertical, or there is a line that goes through the center of the parabola, and we call that the axis of symmetry, okay? On that axis of symmetry, there is a point here that's called a focus, right there. Okay? That focus is special. And if you look at a parabolic heater or a parabolic, like the satellite dish or the flashlight, the transmitter in the satellite dish is placed at the focus. The bulb and the flashlight is placed at the focus of the parabola. Okay? So, what is that? Okay, so how do you create a parabola? So a parabola is the set of all points that are the same distance from a focus and the given line, the directrix. So for example, if I take any point on the parabola here, okay, it's the same. So if I were to take this point here, it's the same distance to here as it is here, to that line, the directrix. Okay, so if I take this point and if I map a line to the focus and a line to the directrix, it's going to be the same distance. If I take any random point, that and that, it's the same distance. Okay, so we have the focus then, that's right there in the middle. Underneath the parabola is the directrix. And the thing is, from the vertex, it's the same number of units up to the focus as it is down to the directrix. So from the vertex, if you go 2 units up to the focus, you go 2 units down to the directrix. All right? So let's just talk about this a little bit. Let's see what all this means. Okay. So you have your vertex, and the vertex always has the letters H and K. Okay? So the vertex is always given as H comma K. Okay? Now, how do you go from the vertex up? How do you go from the vertex to the focus? What do? You add a few points vertically, right? So what are the coordinates of the focus? It's H comma K plus something. Okay? All right, so what is A? A is, remember we always said A tells you how wide or narrow the parabola is, right? So K plus 1 over 4A is how much you have to go up for the focus, all right? Okay, so you can get a parabola that opens vertically or you can get a parabola that opens horizontally. So let's just talk about the vertical parabola for a minute. Okay, so if you have a vertical parabola, this is the equation of it, x minus h squared plus k, okay? The vertex is at h and k, okay? Now, the axis of symmetry. If the parabola is opening vertically, then the axis is always horizontal. I'm sorry. The axis of symmetry is always vertical, okay? If it's vertical, then it hits the x-axis here. So the equation for it is going to be x equals a number, and it's going to be x equals the x-coordinate of the vertex, which is h. Okay, now, what is the focus? So throughout this chapter, I don't want you to memorize a thing other than the midpoint and distance formulas. All these, I want you to reason through it. So what is the focus? The focus is the point here. So if it's a vertical parabola, are you going to go vertically for the focus or horizontally? Vertically. So you're going to change not the h value, but the k value. So the focus is going to be at h, comma, k plus 1 over 4a. It's always that term, 1 over 4a. Now, directrix. If you went up for the focus, where are you going to go for the directrix? Down. Now, the directrix is perpendicular to the axis of symmetry. So the axis of symmetry, if the axis of symmetry was x, then this is going to be y equals k minus 1 over 4a. All right. And I'll talk about lattice rectum in a minute. Let's go now to the horizontal one. All right, a horizontal one. So what's the difference between the equations? A horizontal parabola has the y squared, so it's x equals y squared. Okay, that's how you get a horizontal one. Okay, now the vertex again is h and k. Okay, so if you have a horizontal parabola, then the axis of symmetry is also going to be horizontal, which means it's going to cross the y-axis, right? So it's going to be y equals k. Now, for the focus, am I going to go vertically or horizontally over? For this one. For the focus, I'm going to go horizontally from the vertex, right? So I'm going to change the h value. So it'll be h plus 1 over 4a, comma k. Okay? No. Because you have to switch like the x value and go over. All right? And then what about the directrix? Well, if for this one, if the axis of symmetry was y equals, then this is going to be x equals. And it's going to be in the opposite direction, so h minus 1 over 4a. Okay? So again, I don't want you to memorize any of this stuff. Okay? I just want you to be able to reason through them. Somebody talking somewhere. Okay. And the length of the lattice rectum is 1 over a in both cases, in absolute values. Okay? Okay. So that is basically 1 over a is basically this distance. From the focus, like if you go perpendicular, how far is it until you hit the edge of the parabola? All right, so let's do a couple of examples here. The equations of parabolas can be given in either standard form, which it looks like this, or general form, which is, you know, like what we've used to, like 3x squared plus 5x plus 6, let's say. So here it says express each in standard form. What we're going to do is complete the square. Do you guys remember completing the square? Yeah, okay, so let's complete the square on this stuff. So what we're going to do is this. Here it's y equals. I'm going to lump the terms with the x's together. Okay, so I'm going to factor out a 2. So it'll be x squared minus 6x plus a number plus 6. But it's because it's on the same side, minus 2 times that number. Okay? And what number do I go and put in the blanks? 9. Remember? 9. So this is going to be y is equal to 2x minus 3 squared plus, how much is that? Minus 12. So there we have it. That's the equation in standard form. Now, it says identify the vertex. So the vertex is this number and that number, but it's going to be positive 3 and negative 12. What else do we need here? The direction of the opening. Now, if it's x squared, it opens vertically, and if it's positive x squared, it opens up. So it opens up, and the equation for the axis of symmetry, if it opens up, then the axis of symmetry is vertical, so it's going to be x equals 3. So it opens up, and the axis of symmetry is x equals 3. Okay? All right, so let's do this next one. x equals y squared plus 14y plus a number plus 20 minus a number. What number goes there? 49. So y plus 7 squared minus, how much is that? 29? Is that right? $29 here. Okay, so what's the vertex? -7 and -29. We switch when it's with the in the parentheses and it's squared, right? So we switch the sign. So what about the direction of the opening? Up, down, right, left? To the right. So that means it's a horizontal axis of symmetry. So it's going to be y equals -29. Okay. So this next one, y equals, we're going to factor out a half, x squared. So if I factor out a half from the 12, how much would it be? Not 6, 24, because you're dividing by a half. Minus 8 minus half of a number. So this is going to be 144. And this is going to be 144. So y equals half x plus 12 squared minus, how much is that? 8 plus 72, that's 80. So it opens up, and the axis of symmetry is x equals -12, and the vertex is -12 and -80. Okay, well, let's do the next one quickly. X equals 3 times y squared plus 5 over 3y plus a number minus 9 minus 3 times a number. 3 times, what number is going to go in there? So it's 5 over 6 squared, 25 over 36. So 3 times y plus 5 over 6 squared minus, how much is that? I'm going to cheat and use my calculator on that one. So 133 over 12. So the vertex is -5 over 6, -133 over 12. It opens right, and the axis of symmetry is y equals that horrendous looking number. All right. Okay. So let's graph some of these. Y equals x squared, right? That's your standard parabola. Here. I know we're all experts on graphing parabolas now, although mine looks horrendous. So the vertex is 0, 0. Axis of symmetry, x equals 0. Okay. All right, so what about the focus? How much is A in this problem? A is 1. So 4A is equal to 4. Okay? Now, the focus, remember for the focus, I'm going to go up, right? So it's going to be 0, comma, 1. No, not 1. 1 over 4. Right? Because it's going to be K plus 1 over 4A. The directrix then, the directrix is here. It's going to be Y equals negative 1 over 4. Because if you go up 1 over 4, then you got to go down 1 over 4. The direction is up, and latus rectum is 1. Okay? So let's do the next one. X equals y squared. Now, if I go up, so it's 0, 0. If I go up 1, I go over 1. Now it's switched. And then if I go up 2, I go over 4. So x and y are switched now. Okay. So the vertex is at 0, 0. The axis of symmetry this time is y equals 0. And where is the focus? Do I change the x or the y value for the focus? Am I going to go horizontally from the vertex or vertically from the vertex for the focus? Horizontally. So if this is the vertex, the focus is going to be somewhere here. So I have to go horizontally. That means I make the changes to the h value. So it's going to be 1 over 4 comma 0. The directrix then will be y equals how much? Negative 1 over 4. X equals, I'm sorry, yes. Come on. The direction is to the right, and this is still 1. Okay. Right, and look. Okay, let's just go over to the other one. Okay, so here, so this time, it's shifted right 3, I'm sorry, left 3, up 4. So the vertex is at negative 3 comma 4. So where is the axis of symmetry? It's at x equals negative 3. All right. So in this case, if I go over 1, I'm going down how much? 2 this time, right? Because there is a 2. And if I go over 2, rather than going down 4, I'm going to go up, I'm going to go down 8. So 1 and here. This is how that looks. So here's the axis of symmetry. Okay. All right. So A is equal to 4. I'm sorry. A is equal to 2, the absolute value. Okay. 4A is equal to 8. So if A is negative, if we take it as negative, then 4A will be negative 8. Okay. So now, the focus, where is the focus going to be at? The focus, I'm going to go down, right? I'm going to go down here. So the h value will stay the same. So it'll be negative 3, comma, 4 minus 1 over 8. Okay? So where is that? That's negative 3, comma, 33 over 8. The directrix will be y equals 4 plus 1 over 8. Did I do that right? This is 31 over 8. So this is 33 over 8. The direction is down, and this is just negative 2. Okay? Oh, it's 1 over a.
Yeah.
So it's 1 over negative 1/2. All right? Here, we're at, so where is the vertex here? Oh, sorry. Well, it's negative, well, it's the other way around. X moves negative 3, right? And Y moves negative 5 where? Yeah. So it's, so where is the vertex here? The Y value is 5 and the X value is negative 3. Okay? So it's at negative 3 and 5. And now if I go up 1, I go over 1/2. If I go up 2, I go over 1. So where is the vertex? Negative 3 comma 5. The axis of symmetry is y equals 5. The focus is at, what's going to change for the focus, the x or the y coordinate? The x coordinate, so it's going to be negative 3 plus 1 over 4a. So, okay, so let's do that. So a is 1/2 if I work up here, right? 4a is 2. Is that right? So 1 over 4a is 1/2. So here it's going to be negative 3 plus 1/2, comma 5. So that's negative 5 over 2 comma 5. The directrix, it's going to be x equals negative 3 minus 1/2. So x equals negative 7 over 2. The direction is to the right. And this is 1 over a, which is 2. Okay? All right. So this stuff is to write an equation. Okay, so what I do with these is I always do a little sketch for myself just to see how it looks. Okay, so the vertex is at 1 comma 3. That's the vertex. And the focus is at 1 comma 5. So how does this parabola look? Facing up, down, right, left. What do you think? Up. Right? Because the focus has to be in the middle, like inside. So that means, first of all, that it's going to be, since it faces up, that the formula is going to be y equals ax minus 8 squared plus k. Okay? Now, I know what the vertex is. That's h and k. And since it's facing up, I know exactly where the focus is, right? Because that's going to be at h, comma, k plus 1 over 4a. Does that make sense? So, for my formula here, I have h, I have k, I don't have a. So now I need to use this information to find a. So, k plus 1 over 4a is equal to 5, right? And what's k? Do I know what k is? K is 3. So 3 plus 1 over 4a is equal to 5. 1 over 4a is equal to 2. So how much is 4a then? 4a is equal to 1 over 2. Does that make sense? So what's a? 1 over 8. Okay? So then y is equal to 1 over 8, x minus 1 squared plus 3. There we go. Okay? All right. This next one, I have the focus at negative 5 and 6, so let's just see how that looks. Negative 5 and 6, that's where the focus is. And the directrix is at x equals 2. Okay, so how does this parabola look? Which way does it face? Up, down, right, left? It faces left. Okay? So that means it's going to be, first of all, x equals a y minus k squared plus h. Okay? All right, so what do we have here and what do we need? If the vertex is h and k, where is the focus in this case? The focus is at h plus what? 1 over 4a, comma k. Okay, so remember, we need to get a negative value for a, right? Okay, so how else can we solve this? Where would the vertex be in relation to the focus and the directrix? So from the vertex, if you go 2 units to the right, you need to go 2 units to the left to the directrix. So this is exactly, the vertex is exactly in the middle of the focus and the directrix, right? So this point here is the point 2 comma 6, because this is negative 5 comma 6. Does that make sense? So where is the vertex then? Can we find the vertex? Vertex is negative 5 plus 2 over 2. It's the midpoint, comma 6. Does that make sense? So the vertex is where? Negative 3 over 2, comma 6. Is that right? Yeah? Am I right? Okay. So how do I find A then? So from here, the focus is at h plus 1 over 4a, and that's at negative 5. Okay? So what's h? Negative 3 over 2 plus 1 over 4a is negative 5. So let's find 4a. 1 over 4a is negative 5 plus 1.5. How much is that? Is that negative 3.5? Is that right? Negative 5 plus 1.5 is negative 3.5, so negative 7 over 2. Okay, now, if 1 over 4a is negative 7 over 2, then what's 4a? If you flip the fraction, then 4a is negative 2 over 7. So 28a is equal to negative 2. A is equal to negative 1 over 14. Look, we got a negative number, right? So then we plug it in. Y minus, what's k? 6 squared plus h. Okay? All right? Okay.